Hi everyone! In this simple stack demo, I'm going to show you why in general we should favor composition over inheritance. Using composition allows us to revise our software design if necessary, providing more flexibility. Inheritance mistakes can be costly, especially if the program is used by many people. I'm going to use a classic example of the incorrect use of inheritance in the Java library to illustrate this design principle. More specifically, I'm going to discuss how Java util stack was implemented and what was wrong with the implementation. A stack is a data structure that implements the LIFO or last in first out behavior. A stack has some basic operations such as push, pop, and pick. These operations allow one to store, remove, or see an item in the collection. These operations are limited only to the top item on the pile. For example, you can only pick or remove the top elements on a stack. Let's create a stack of integers and push some numbers onto it. We can use pop to remove the top item on the stack. The problem with the implementation of the class stack in Java is that it extends the class factor, which means that stack inherits all non-private methods from factor. Factor is a list and supports operations beyond the LIFO abstraction. A stack, however, is not a list, so making the class stack a subclass of factor is incorrect in the first place. As a list, factor allows you to remove an item at a specific index. It doesn't matter whether or not the element is on the top of the stack. Consequently, the class stack breaks the LIFO abstraction. As shown in this video, it's possible to remove the item at index 2 from the stack. A pure stack shouldn't support such an operation. To support backward compatibility, Java must continue supporting the broken class stack. Fixing the class stack will break existing programs that use it. Note, however, that Java has developed the Java Collections framework, which includes the DEC interface or double-ended queue, and recommends using it instead of the legacy class stack. Composition offers an alternative to inheritance. To demonstrate this approach, let's implement a simple stack class that supports the stack's basic operations such as push, pop, and pick. Simple stack uses a factor to perform most of its behaviors. Simple stack doesn't need to extend factor to get the benefits of code reuse. For the time being, don't worry about the type parameter e. This is part of the generics programming in Java to allow client code specifies the type of simple stack it wants to create. For example, we can construct a simple stack of string, a simple stack of integer, or a simple stack of some other object type. This type parameter is used as the return type of the push, pop, and pick methods. We provide a constructor for creating an empty stack. When this constructor is called, we create a factor object to store and manage items within the stack. We then implement the basic operations of the stack, which include push to store an item onto the stack, pop to remove the top item on the stack, pick to see the top element without removing it from the stack. Both pop and pick will throw an empty stack exception if the stack is empty. We also provide a method that returns a Boolean value to indicate whether or not the stack is empty. The code to implement these operations is quite simple because we delegate many details to the factor object. For example, we don't have to worry about keeping track if the factor is full or the number of elements in the collection. If for some reason we want to change the implementation details of simple stack, such as replacing the factor object with an array list, we don't need to change the API of this class. In other words, such change will not break the client programs that use the class SimpleStack. Let's modify the main function to test SimpleStack. We construct a SimpleStack of integer and push some values onto it. Before I run the program, let me comment out the other statements so that you can focus on the relevant code and output. The behavior of SimpleStack adheres to the LIFO abstraction because it doesn't extend and therefore inherit methods from another class. Yet, it supports the basic stack operations such as push, pop, and pick. In summary, this demo illustrates a software design principle of Favour compositions over inheritance. Although both approaches allow code reuse, using composition offers additional benefits, such as flexibility and encapsulation. Details of how we implement a class are hidden from client code. For example, if we decide to replace the vector object in SimpleStack with an array list, the client code wouldn't notice anything. So next time you're designing your software, think carefully before jumping into using inheritance. Inheritance can be useful in certain situations, but there is a good chance that you may produce a better software design by using composition.